Hi, welcome back. In this video, we're going to look at calorimetry and how to solve a calorimetry problem. So calorimetry is a way that we can indirectly measure heat change. And what happens is we add two substances together and we measure the change in heat that occurs when those two substances are added together. So with our two substances, we can solve for Q of each substance. Remember, Q is equal to mc delta T. And with calorimetry, because we're using two substances and adding them together, we can say that the Q of one substance is equal to the negative Q of the other substance. Or in other words, however much heat is being absorbed by one substance has to be the amount of heat that's being released by the other substance. So the Q of one of the substances will be equal to the negative Q of the other substance. And that allows us to solve for all four variables Q, M, C, and change in T if we want to. So let's try this problem together. It says some copper at 2.3 degrees Celsius with a total mass of 83.2 grams was added to some water at 92.6 degrees Celsius. What mass of water was present if the final temperature of the mixture was 76.71 degrees Celsius? So we're looking for the mass of water, which means first we want to solve for the Q of copper. We have everything we need to solve for copper, so we'll start with that. So Q of copper is equal to mc delta T. M is the mass, which is 83.2 grams. C is the specific heat, which you can find by looking at any table online, and that is 0.385 joules per gram degree Celsius. Change in T is the final temperature minus the initial temperature. Final temperature was 76.71. And the initial temperature of copper was 2.3 degrees Celsius. So the change in temperature is going to be equal to 74.41. So all that we have to do is multiply all of these things together. So 83.2 grams times 0.385 joules per gram degree Celsius times 74.41 degrees Celsius, which is equal to 2,383.5 joules, 2,383.50 joules. So that means that the Q of copper is equal to the negative Q of water. So the Q of water is equal to negative 2,383.5 joules. And we want to know what is the mass of the water that was present. So our mass is unknown. The specific heat of water is 4.184 joules per gram degree Celsius. And if you didn't know that, again, you could look that up in a table. The temperature change is the final temperature, so it's still 76.71 minus 92.6, which is equal to negative 15.89 degrees Celsius. So remember, Q is equal to mc delta T. We need to rearrange this formula to solve for M. So M is equal to Q over C change in T, which is equal to negative 2,383.5 joules over 4.184 joules per gram degree Celsius times negative 15.89 degrees Celsius, which is equal to 35.8 grams. So that is how you solve a calorimetry problem. You solve for one Q first, the Q that you have all of the data for, and then that equals the negative Q of the other value, and you use that to solve for your missing variable. One reminder as well, if copper had been a negative value here, then water would be a positive value. So the two will always be opposite of each other. If one is absorbing, the other has to be releasing the heat. I hope this was helpful. Make sure and check out other videos on my channel. Thank you so much for stopping by.